But my dad was like, you work early in the morning, and you were like, it was so weird.
Alright, let's get started, please. So we got AP Stats test scores. This is actually like lower than normal. I don't know why I put this on here. So this is saying like 25% of people get one. Let's do part C first. Do the probability table. It's easier to see what's going on. So 1, 2, 3, 4, 5 are your potential scores. So what I'm saying here is 25% of people get a 1, 20% of people get a 2, etc. This is actually kind of flipped around from how it typically looks. Like historically, something like 75% of people have passed this test. Even last year, even in COVID. Okay, so the variable of interest is the AP test score. Let's go ahead and do part D and E also. So you gotta do that. Do part D and E. Run it through how to do it with the calculator again. We'll do the new stuff. So that's what I got. So just make sure you're matching up, getting the same thing. If you're not, let me know if I can be of assistance. We good? We getting these numbers? Okay. Okay, so go back up to continuous and discrete. So continuous means infinite values. Infinite are all values. All values are decimals. Are possible. I'm not sure that's the most grammatically correct sentence with all those slashes, but I'm saying like you can get any value, any decimal. So like there's a rule in math that says no matter how close two numbers are, I can put one in between them. So like time, measuring time to run 100 meters, for example, is continuous because it may take you like 12.3 seconds. It might take you 12.31. It could take you 12.311, 12.31112. That decimal could just keep. You could just get more and more and more precise. Measurements, measuring in centimeters or something. Like I'm building a house, I need to know how big this piece of wood needs to be. 2.527365. Like it could go on forever and ever, and you could get as precise as you want it to. So every single value is possible. Discrete is only certain values are possible. So go back to continuous. Your grade percentage is continuous. You could have an 87.813652999%. But your grade is discrete. You get an A, an A minus, a B plus, a B. You know, you don't get like a B plus 0.5. Your test, these AP test scores are discrete. You can get 1, 2, 3, or 4, or 5. You can't get anything in the middle. There's only certain things that are possible. So like AP score, grade in percent of the grade. The grade you're in. You're in 11th grade, you're in 12th grade. You can't be in 11.25731 grade. So all the stuff we've been working with these tables, is all what? Continuous or discrete? It's all discrete because you get these, you know, you could win $100, $50, or lose $100. I'm giving you like these fixed outcomes. Those are the only things possible. So is the AP test. And then, so we've done all this stuff like mean and standard deviation with discrete, and then next week we do it with continuous. We gotta summarize those, and we'll have a test probably early the next week, I'm thinking. So is the AP stats test score continuous or discrete? That's right. That's discrete, right? Because there's only certain outcomes that are allowed. That's the first kind of new notes thing. And then go down to variance. Variance is just standard deviation squared. Just say yes. Like you're rooting for the standard deviation to be squared. So kind of the idea is standard deviation gives you like the average distance from the mean. The variance gives you kind of like the average. You could go all the way from one extreme to the other. Simplified way to say it, but not too bad. So the variance, you just take the 1.37 from part E and square it. 1.877, let's say, somewhere around there. Fair enough? Alright, let's go to the next page. Am I good to go? Or was anyone still looking at that first page? Okay. So now I got AP Calc test scores. So let's do, I'm going to do the probability table first, just because I think that helps me see what's going on. I called this Y on purpose because we're going to start combining the stats and the calc scores. They need to be different variables. I called stats X, I called calc Y. So, 1, 2, 3, 2. Your variable of interest is the AP Calc score. Continuous or discrete? Discrete. You can only get a 1, 2, 3, 4, or 5. There are no other options, nothing in between. Then go ahead and calculate all that stuff. They represent different, they're very similar, but so the kind of concept is like if I have -5, 0, and 5, I got like a distribution here. They just are two different ways of talking about the same thing. So standard deviation here might be 5, because that's like the average distance from the middle. The variance is like if you're going back and forth, like it represents more of like how big is the gap between the two endpoints. That's overly simplified, but it's really two ways to describe the same thing. So you don't necessarily need both, I guess. But I feel like that's a crappy answer, but that's about all I got. All right, questions on any of those? You guys get the same stuff? We good? Okay. So then, what I have, if I were to kind of summarize, I've got for stats and calc, I've got a mean. I'm making a little table here and a standard deviation. So for stats, my mean was 2.76. For calc, my mean was 2.74. For stats, my standard deviation was 1.37. For calc, it was 1.29. So this is me just like summarizing. Probably should have left you some space here, but here we are. So yesterday we talked about like if I have a mean and a standard deviation and I like add 10 to every data point. Let's review that. So if I have like if I take the stats mean and standard deviation and I add 1, the AP test is like we're gonna curve. Everyone sucked this year. We're gonna curve the AP test. We're gonna add 1 to every score. If I added 1 to every score, what would the new mean be? 3.76. What would the new standard deviation be? 1.37. That wouldn't change, right? And then we also said, like, okay, what if we doubled it? What if theirs being super generous? We're going to double every single AP score. So what would the new mean be? It would be that times 2, right? And would we double the standard deviation also? Yeah, we would. So now we're going to say, now we have 2 distributions. And we're going to bring those 2 distributions together. I'm going to make a new distribution that represents stats plus calc or stats minus calc. So if I randomly pick an AP stats test and an AP calc test and add them together, what is the mean? We just add up the 2 means. This would be 2.76 plus 2.74. I think it's 4.5. No, 5.5. So the means act, again, the means do just what you'd expect them to do. Whatever you do it to the mean. The mean just like acts how you think it should act. If I randomly pick an AP stats test and subtract a randomly chosen AP calc test, what's the expected value? Stats is 2.76, calc is 2.74, so I get 0.02. Makes sense, that's just the difference between them. Those 2 okay? Alright, what is the probability if I take 1 of each score, add them up, I get at least 9? So, this is really a gigantic tree, but I'm isolating like a small part of it because the tree would be enormous. But if I made a tree, don't do this. It's a giant waste of time. But 1, 2, 3, 4, 5, like that represents my stats, let's say. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to do all of those. So those are all my possibilities. And I want to know what's the probability if I take 1 of each and add them up, I get at least 9. Well, if I want at least 9, do I give 2 craps about these, the top 3? Like the most I can get if I got a 1 on the first test, I can't get to 9, right? If I got 2 on the first test, I can only get to 7. If I got 3, so the only branches I care about are that, and that, right? That's the only ones that add up to 9 or more. So I'm not going to make the tree. I'm just trying to show you like why we're picking what I'm about to show you. So to get at least 9, I would need like a 4 on stats and a 5 on calc. Or I would need a 5 on stats and a 4 on calc. Or I would need a 5 on both. Agreed? Let's just pick out like that part of the tree without drawing the whole tree. Well, what's the probability I get a 4 on stats? 0.18. And I would need to get a 5 on the calc. 0.11. The word and typically means multiply. Multiply those together. Or, the word or typically means add. I could get a 5 on stats, which is 0.14, 4 income. Or, get a 5 on stats. 4. 5 on count. 1 total. So I've got these 3 possibilities. I can have this and this multiplying together. Or, so add this and this multiplying together. Or, this and this multiplying together. And we're going to add all 3 of those up and see what we get. So again, it's really just the tree. I'm only worrying about the part of the tree that I'm being asked about instead of making a 25 branch tree. Figure all that out. So you guys got that? Is it? Question on that? What I'm doing to get that? Try number 7 then. So I take one of each score. I get no more than 3 when I add them together. Are we good? Are we at the point where you can try it, or should I be doing it? We're good. Try no offense, but you're useless. Trent's useless to me. What if I was like, ask a certain person, like, do you get it? Because if you get it, I know we can move on. How mean would that be? Connor, are you good? Well, then everybody must be good. Oh yeah, you guys got the view today, huh? Pirates. The order you do them in doesn't matter, so like, if I'm doing a different order than you did, it doesn't make a difference because you're just going to add them anyways. I got 0.1535. Am I asking the same thing? So just to go through what I'm doing there again, the way you can get no more than 3 would be like a 1 and a 2, 2 and a 1, or a 1 and a 1. So we're just picking out different parts of this gigantic tree. It'd be the 1 and the 1, the 1 and the 2, or the 2 and the 1. But I'm bypassing doing that whole tree and just kind of zooming in on what I need. So go ahead and do 8 and 9 if you haven't done that yet. So like number 8 is zooming in even more. There's literally only one branch on the giant tree I care about. You have to get a 5 on both. And then same with the x plus y equals 2, you have to get a 1 on both, so there's only one combination or one branch that I care about. So I got those two numbers. You guys just looked up at the exact same time. Florida. Alright, those two okay? Alright, so combining distributions, this is just kind of summarizing. To combine the means, you add or subtract. Combine the standard deviations is where it gets a little tougher. So, if I have a like the standard deviation of A, it's basically Pythagorean theorem. Right up Pythagorean theorem. The standard deviation of A plus B. That's how I would write that. Standard deviation of A plus B is the square root of standard deviation of A squared plus the standard deviation of B squared. I feel like that sounds way more intimidating than it actually, or looks way more intimidating than it actually is. It's literally doing the Pythagorean theorem. So if I gave you so if I gave you that's 3 and that's 4, does everybody remember what that third side is? That's going to be 5 every time. And the way that's happening is you're going 3 squared plus 4 squared equals c squared, and then 9 plus 16, so that's 25, equals c squared, and then that side would be 5. Well, if I told you the standard deviation of A was 3, and the standard deviation of B was 4, and I asked you for the standard deviation, like this is, let's say this was the standard deviation of the calc scores, this is the standard deviation of the stat scores, and I said add those two together, what's the standard deviation of those two things combined? It's the same exact thing. You would go square root of 3 squared plus 4 squared. So it's just the square root of the first standard deviation squared plus the square root of the second standard deviation squared, and that would be 5. It's literally Pythagorean theorem. So, we already did 10, 11, don't worry about that. So what is the standard deviation of x plus y? Well, the standard deviation of x, which was stats, was 1.37. The standard deviation of y, which was calc, was 1.29. So the standard deviation of x plus y is basically find the hypotenuse. So you do the square root of the first one squared plus the second one squared. So I get 1.88. kind of weird thing. I won't say it yet. So if you want to go back up here. Oh, no, never mind. Okay, are we got a 1.88? The kind of weird thing is if I ask you for the standard deviation of x minus y, it's the same thing. Whether you're adding or subtracting these two distributions, you are adding together errors. So let me phrase it like this. Don't calculate yet. See if you can pay attention. This is kind of hard to follow, but I'm going to do my best. AP Calc scores have a standard deviation. Like they have an error, they have a kind of a margin, a window that they're in, right? And then the AP, I forgot if I just said Calc or Stats, but the other one has a window also. So when you combine them, doesn't it make sense that window should get bigger? Like if I'm trying to guess Evan's weight and I'm trying to guess Will's weight, I'm going to be off a little bit on both. And when I add those two that I'm off by, I'm going to be off by more, right? I might be off by like 5 pounds on Evan and 10 pounds on Will, but now I'm off by 15 total. I added those together. I think that makes most sense to most people, to more people. But I often get this question, well, if I'm subtracting, why wouldn't I subtract the standard deviations? So, my best explanation for that is, let's say that I'm going to pour, you give me a glass and you say, pour 8 ounces in this glass. I don't have a way to measure it. I'm just going to try to pour 8 ounces in. Well, I'm going to be off by some, right? Like, there's going to be a standard deviation, there's going to be an error. And then you say, now pour 4 ounces out of it. I'm going to be off some there also, right? So when I combine those two that I'm off, wouldn't I add, now I'm going to be more off at the end than I was at the beginning, right? I'm going to add those two errors. I wouldn't subtract them. Or look at it this way. If I'm trying to guess Evan's weight, I'm going to be off by a certain amount. Now subtract Will's weight. I'm going to be off by a certain amount. Well, those two errors are just going to compound. They're not going to like cancel each other out. I'm not going to subtract them. It's a hard concept to understand. I'm not sure I do a great job of explaining it. But this is kind of your go-to. It doesn't matter whether you're adding or subtracting the two distributions. You do the Pythagorean theorem anyways. For doing what? There's no difference. I was trying to explain why. I don't know how well it went, but it's the same thing. Yeah. And you can ignore everything I just said. Just be like, so it's the same thing. Yeah, that's fine. So what's the standard deviation of x minus y? 1.88. It's the exact same thing. So it doesn't matter if you're adding or subtracting the distributions. You are compounding the errors. So you need to add up those errors that you're making. Whether you're adding or subtracting the distributions, it doesn't matter. So what is the variance of both of them? So how do I get from standard deviation to variance? Squared. So 1.88 squared is 3.53. 1.88 squared is 3.53. Alright, let's go to the back and see if we can kind of put some stuff together here. Alright, siblings. So this is saying 10% of the people in my class have 0 siblings. How many only children in here? Anybody? Am I an only child? None? 40% have 1 sibling. How many have 1 sibling? Okay. 2. It's 30% in my example. How many have 2? 3? Am I more? How many? 4 more than 3 or 4? 4, okay. 4. I had one with 11 one year. 11 siblings. Anyway. Continuous or discrete? Discrete. Those fixed number of options. You can't have like 2.1 siblings. What is the expected number of siblings that someone has? How do we find that? That's the mean. So put in your, I'm not going to make the table. I'm going to try to not do the table. So put it in your calculator. Figure out the mean, standard deviation, and then do the variance also. This is kind of weird for people because, you can't have 1.6 siblings. I get that. But if I were to ask a billion people, the average, if this information is true, would be 1.6. Standard deviation, I get like 0.917, and then to get the variance, I square that. So 0.84. Yeah. Good when I gave it to you. What do you mean?
Like, I just don't get the same numbers as that.
Seriously?
Yeah. And I put it in right.
Are you just hitting it there? So remember that information here.
You were
Wait, you know really big.
no.